today we'll be learning about the Kadane algorithm. First, we'll understand the brute force solution. Then we'll understand how the linear time solution works on the iPad. Eventually write the code in linear time and then submit it. Hey guys, how's it going? Today we'll be solving maximum sum subarray problem. And if you have come to this video, you probably searched all over the internet, maybe YouTube, and you were looking for something really simple. I'll try to keep it short and simple. And the problem that you see or solution that you see over here is a brute force solution for maximum subarray. The first intuition that comes in is just find all the subarrays and then choose the max. That's all it's happening here. You can also do in the cubic time if you're not using a couple of optimization, as you can see here. So it's just like two loops. The inner loop is trying to find all the possible subarrays and choosing them and keeping the maximum as a value saved and comparing it with the current max. I'll be creating a story for you guys about a father and a selfish son, where selfish son thinks that he's gonna make the maximum value, but the father is the one who keeps him in check, and to get the maximum value we're gonna trust the father in the last. So keep sticking to the video, do watch the iPad solution. So guys, we'll be finding the maximum sum subarray. The input given to us is 2, -1, 3, -3, and the output is 4. So we'll be finding the subarrays and the maximum subarrays to be precise. So we'll start finding the subarrays now. So for the first one, the subarray is just 2, right? And the second one is just 2, -1, 2, -1. So these are the subarrays that you can see I'm writing here now. And for the next one, it's again the 2, all the individual items, and then grouped items into pieces of 2, and then you have the complete subarray 2, -1, and 3. This is how you can find the subarrays. And now let's start creating the subarrays for 2, -1, 3, -3. So 2, -1, 3, -3, and then you have all these items in groups of 2. So 2, -1, then you go -1, 3, then you have 3, -3, and then you have 2, -1, 3, and then you have the whole subarray into consideration in the last. So I'll explain the Kadane algorithm in a very simple way. So let's assume that each element in the array or the subarray that we are considering is a selfish guy, and this selfish guy treats himself as the maximum in the subarray, or he smartly takes a move where he considers himself adding himself to the max of the previous subarray just before him that occurred, and addition of that he thinks that this will be going to be a maximum of the subarrays. So this is the trick that these selfish guys are doing here. So let's treat every element as a selfish guy and then move forward. For example, now, so the table you see here, we have state, subarrays, comparison, and max, C and G. C is the current max, G is the global max. In a sense that we said that every element here in the subarray or the array is going to be selfish. So the current max is going to be what he thinks of himself. Like if he thinks that he is the maximum in that subarray, we'll assume that alright, he's saying the truth. Then G is the global max, which we think is the father of C, and he'll keep C in check. Alright, he'll let him do whatever he wants, but then we only consider what G says is the truth. So guys, let's start with 2. So 2 is the first element of the subarray on the array, and there's no comparison because we are assuming that 2 is the current max and the global max. We're going to copy the value 2 to C and G, right? And now the index would move on to -1, and but -1 is selfish again, right? So he's gonna think that either he's the max, like he's the one who can create the maximum sum in the subarray, or he could just pick someone from the last max, which is current max, we have value as 2, and add it to himself, and he would think that alright, I can make this value as maximum now. So he's really selfish and smart. That's what it does. But in the meantime, what it does was the C becomes 1 and G becomes 2. So the father knows that it's 2. He will not do anything. He'll just keep it that way. So now the index moves on to 3, and 3 is going to be selfish, but we already computed the maximum subarray of 2, -1 in the above step, and that is current max, which is 1, and which you can see in red, and I've highlighted that. But 3 is again going to be selfish, and he's going to think that either he himself is going to be the max in the subarray, or he adding himself to the previous current max would be the max, or would be contributing to the max. He's very smart on these lines. And again, the father would let him do it, but this time the father sees that, alright, he made a 4, right? And it's greater than 2, which was the global max. He'll update himself as well. Moving on to the next one. So now the index is at -3. We already have a subarray or max subarray computed from this red zone to -1, 3, and it is 4, and we already have it as a current max. So again, my -3 is going to be selfish, treating himself first, and -3 plus the current max, which is 4, it gives us 1 as a current max. And but father is very smart, he's not going to update himself, he's still going to stick to 4, and that is going to be our answer here. So Kadane's algorithm is an idea where we are trying to find the maximum subarray till that point in the index by evaluating all the subarrays which were done previously. So we're making of that. So here's a linear time algorithm which I'm going to show here in a couple of seconds, and we'll also code and we'll see how this fits into that. It's a very short code, surprises a lot of people, but it works. So guys, we'll be taking example as 2, -1, 3, -3. So to start with, because we have the first index and the element as 2, so we won't have anything to compare with, and let's assume that that is the max, and that is the selfish kid that we talked about in the explanation. So let's go ahead and just create a variable like max till previous. So this is the maximum of the subarray sum that we have encountered till the previous index of where we are right now. So that we don't have, so what we do is like we initialize it to 0. So here we assume that the selfish kid is 0 and he's trying to make himself as max, and that's where he is. And now we'll have something like global max, which is the father, which will keep all the nodes in check, all the elements, all the selfish kids in check, so that they don't mess up with the maximum element which has to be returned at the last, the maximum sum of the subarray which has to be returned in the last. Because now we have already started with the first element, what we'll be doing is like we'll be moving on to the next element, which is -1. For that, it's like the next indexed after 0, which is I equals to 1. That what we'll be going to do is we'll be starting the loop and iterating over all the elements, but it will start from -1 now. So the selfish guy is there, so he'll do a compare, and he'll compare himself for the max numzi versus numzi plus, it's like max till previous. So he's going to compare that, and if he finds that something is maximum, he'll replace. If he finds max, then replace max till previous, right? So how we can represent that in the code, it's just that what we need to write is like max till previous equals to math.max, and then nums I plus nums I, nums I plus max till previous, right? So very clear, it's a very simple statement, and I've already mentioned why it is being done. It's because numzi is going to be selfish here. He's going to treat himself as maximum, or he's going to make use of whatever the max that occurred till the index just before his index. So now I have a global max, which is the father, right? So here as our father, here's like I can write selfish kid here because it's num0's value. So yeah, but now the selfish kid keeps on changing from time to time, because every time we move into the next index in the array, that's going to be a selfish kid. So here the father is going to check whether the kid or the max till previous, right, has been really been affected or not. Like, is there a max or not, or just the kid is like joking around? So let's have max till previous. So he's going to compare this with whatever he knows, right? He knows global max underscore father, and that's what he knows about. And so here what is happening is like max till previous, right? So father knows the father variable, right? The father knows that max till previous can only be less, right? And if it's going to be more, father's going to catch it and also save it in its place. and it replace it in this variable. So that's what we are going to do, right? So we know that max previous could mess up. He could lose on some maximum values, but if it gets lesser than the global max, that's where he ignores it. The father definitely ignores it. And in case it doesn't, and if it is more than what the father knows, it replaces its own value with the new max. So that's what is happening here. Then we're going to increment the pointer. I think we are done with the code. There's nothing much to do here. Yeah, and we return like global max because we trust the father than the kids, right, in this case. So yeah, I think this should work. Let's see. Let's try to run this code. This works. Let's try to submit this code. It accepted. So thank you for watching video, guys. I'll see you in the next video. If you really like my video, do subscribe, do like, and do comment on this video. Thank you.